Guys, we did put some manipulatives, some tools on your desk, and I'm gonna remind you those are just sitting there right now. In a minute, we're gonna get into them, okay? But for right now, let's look up here and focus on our learning goals for today. So I'm gonna ask for some help because you guys are old enough to help out with this. Would someone like to read to us our first learning goal in our lesson, unit fractions? Okay, let's move on.
I can represent fractions by separating them into sums of a unit fraction.
All right, good job. Let's read it together. I
can
represent fractions by separating them into sums of unit fractions. Ooh, so exciting. Okay, next one. All right, go ahead.
I can represent fractions by joining unit fractions in more than one way.
Good job. Okay, let's read it together.
I can represent fractions by joining unit fractions in more than one way.
So we're going to be representing what?
Fractions.
Sometimes we're going to be, what is this? Separating. Sometimes we're going to be joining. And we're going to be working with unit fractions, and we're also going to be working flexibly to do it in more than one way. All right? So what you're looking at on your desk then, these colored rods, are one way that we're going to represent fractions today. Got it? Right, so I'm not sure how you guys, sometimes teachers use different language, but I'm going to tell you what I usually tell students about our math tools. So these are a tool that we're going to use to work on some math today. We use tools to work, right? But they look pretty fun, don't they?
Yes.
Yeah, they're pretty fun. I asked my son, who's 25, if I put a group of these on his desk when he walked into school, when he was even in college, what would he want to do? And you know what he told me? He would want to play with them. And I get that. So we are going to use them as tools, but as I get to the next slide to get us ready, I'm going to let you open them up, and for like 30 seconds you get to play with them. All right? So take the lid off, and for 30 seconds, just play around with
Hey guys, can everybody move their water bottle down by their desk? That way it doesn't get in the way.
There you go. Oh, it'd be nice if they had connectors. That would be a whole other way that we could play with them.
I built a tower.
They're meant to be separate.
I built a
All right, I'm going to wrap it up in 10.
Yes.
So 10 seconds.
I made a block of mine. It's not hard to balance.
All right, and that's it. So hands off. Hands off. We're now out of toy time, and we're into what kind of time? Learning time. So that means our blocks are no longer toys, but they are tools. All right, so I'm waiting for all hands off because it's going to be an important part of us being able to get through our lesson. All right, so I can already tell how creative you are. You guys built really cool things in like 30 seconds. All right, so here's what we're going to need. Listen carefully. I want you to get out one dark green colored rod. One dark green, just one dark green. Yep, hold it up and look around, see if you have the same color green as all your friends. That's exactly the one that you need. All right, now here's the other thing. I'm going to say some other colors that you're going to need, and I only want you to have those colors out on your desk.
Okay.
All right, so you only need the one dark green, but you're also going to need some white. So go ahead and grab several of the whites. You might have to grab some more in a second, but get out several whites.
How much do we get?
Just grab 6, 7, something like that.
Hello.
All right. So right now you have one dark green, you have several whites, and I also need you to get out a few reds. Grab some reds.
No, that's what I'm helping Parker.
Three or four reds. Three or four reds.
I got 4 reds.
Okay.
I'm good.
All right. Here's what we need next. Let's do 4 light green. Get out 4 light green. 4 light green. So we've got white, we've got red, we've got light green, and we have our 1 dark green.
You said 4 light green?
Yeah, 4 light green should do it. Okay. Let's get out 2 yellows. 2 yellows. That's good. And one more color that we're going to need is, let's do 3 purples.
Purple's got my pile.
3 purples.
Colors are all good. I don't know how to make it.
And then we can put the lid back on and then
All right, to the side. So now you're going to put the rest of them, if you can, just drop the lid on it. If you can slide it right inside of your desk, that'll give you a lot of workspace. Won't be in the way. If you have the bag, you can just put the rest in the bag and put it to the side, then it doesn't take up as much space. All right, so everyone, you did a great job following directions, and now here's where we start to represent. All right, so right now you have all those colors out. I understand the need to organize them. I am the same way. It's interesting to see how you're organizing, but I'm going to ask you to take your hands off. I'm going to ask you to grab the dark green. All right. I want you to put the dark green right in the middle of your desk in front of you. If you've got things there, move it. All right. So the dark green is going to be our whole. It represents 1 whole. Okay. So what's the dark green?
1 whole.
1 whole. You have some other colored rods that I would like you to use to represent 1 whole, if dark green is 1 whole.
Okay.
Yep, so you're just gonna think about it, maybe play around. I would advise you to just start moving some of those other colors around. See what other colors you can use to represent the whole, which we know is dark green. Representing this dark green 1 whole. But you said red too as well. But I'm noticing you said these 2 are the same one, which was 1 whole. So can that be 1 whole if it's not the same one?
Sure, why not?
Yeah. All right, now here's what I would like you to do. All right, you are mostly next to a shoulder partner. If you're not, then we're going to help you find a partner to compare with, okay? What you're going to do is your hands are off your colored rods. You have all built some representations of whole, of 1 whole, with dark green being the original 1 whole, right? Now you're going to get a chance to look at a neighbor's models of 1 whole and see what you did the same and maybe what you did that was a little bit different. All right? So you 3 can actually all look at each other. So go ahead, if you have questions, ask your friend. How did you do that?
Interesting.
All right, guys, so I'm going to bring you back. Ready? 3, 2, 1, eyes up here. Okay, let's talk about it. Where's let's do a quick hand check. Where's everybody's hands? They're not on their tools, are they?
No.
No.
Oh God.
It's okay. It's all right. All right. I know it's so tempting to rip, but remember, it's not a toy right now. These are our tools, and we're using them to represent. All right. So you can go ahead and put your hands on your lap, but I want your eyes up here because I want you to help me with something. Which rods did you use to build one hole? Let's do this really quick. All right, back here in the red shirt. Which rods? To give me one. What did you use to represent the one dark green?
One purple and one red.
Ooh, so did anybody else give me just like a, you guys do
We
agree
do
or
a thumb up. We do a thumb up.
Anybody else do a purple and a red? All right, nice. Let's do another one. Okay, go ahead.
I did 6 ones.
6 whites represented one hole. Okay, got a bunch of people saying, yep, 6 whites, okay. What else? What'd you do?
I put a purple and 2 whites.
Okay, so instead of the red, you had 2 whites. So we have a mixture again, purple and 2 whites. Maybe we have some more of those. What'd you do?
I did 2 greens and 3 reds.
2.
Just
Oh.
one at a time. Do this
2
one.
greens.
Two greens.
So 2 greens were equivalent or the same, right? They both represented one hole. I see your thumbs. Okay, let's do. Did we do just red? Did anyone figure out how would red work?
Yeah.
What was that? 3 reds. How many of you got the 3 reds? Okay, so let's put our hands down for 1 second. Let's go back and talk about. You ready, Parker? All right, let's go back and talk about the yellow ones. Did anybody find a way to make one using a
I
yellow?
did.
Okay, so Sophie,
I did 1 yellow and 1.
is that what you guys got? One yellow, one red?
Yeah.
All right, so what are you noticing about the different ways that you can make, use the rods to represent and make one whole? What are you noticing?
They're each divided, the whole number, but divided into a number.
Oh, so we were separating
Yes.
that whole into different parts?
Divided.
Yeah, I like that. So you're right, that would be a form of division. Yeah.
They're each in like their own, like they're in different colors, but like you add another color on them.
So sometimes, not always, but sometimes we have a color like yellow and then we have to add
Oh, like a white.
a white, which you said was 1. You were thinking of as
Yeah.
1 more? All right, but did we always have to use more than 1 color?
Oh yeah.
I want you to pull out right now the ones that you only use the same color. So we said, an example, 3 red, right? 3 red made dark green. What's another one that you use the same color more than once? Go ahead.
2 greens.
What color? Green. What kind?
Like
2 light greens. So we should have red, light green. They're all next to dark green because we're representing one whole. Is there another one? What is it?
all 6 whites.
6 whites. Okay, so let's pull that one down too. All right, so when we have the white rod, or the white colored rods, how many did it take to make the one hole?
6.
Everybody tell me.
6.
All right, so what would one of those whites be? What fraction? If my whole is 1 and I separated that whole into all white, you said there would be 6. So what would one of those white represent? What fraction, Daxton? 1/6. Was anybody else thinking that?
Yeah.
Okay, so you're telling me that that fraction for the white would be 1/6. If I used words for this, just to make sure, because this is a tricky one, I'm not saying 6. What am I saying?
6.
6. It's right there, isn't it? 6. 1/6, right? So I have 1/6, not more than 1. So I would have 2/6. I would have to add an S, right? But this is 1/6. Does that make sense?
Yeah.
All right, so if I had 2 whites, what would I have?
2.
2 6. And I've had 3 whites, I would have.
3.
And how many whites would make a whole?
6.
So what would that look like as a fraction? 6.
3.
6.
3 and 6.
Okay, all right. So let's go back to the yellow one.
Yellow.
What's the yellow one then?
Oh.
Think for 1 minute. I love that you got your hand already, but I want you to think for a minute.
Oh.
Here's what I want you to do, because hands are starting to come up and I can see it on your face. I want you to talk in your group there. Go back to that same partner and talk. What do you think?
Yellow. White is 1 6. What's yellow?
What is the yellow? What fraction does the yellow represent?
5 what? 5 6. Why?
Did you agree with that?
Yeah, oh my goodness, Skylar, that was beautiful. Good job. That was great. Great explanation. Good.
Very
Did
good.
you all hear what he said? Explain that to your group again.
Would you like to, because I'm hearing some great things too.
Yeah, Skylar,
Okay.
why don't you go ahead and tell the class what you said? What did you say the yellow would be worth?
The yellow would be worth 5 6 because if you compare it to the dark green, you'd only need 1 white to make it 1 whole.
And that's kind of what we were seeing over here. So then we determined that if we looked at that yellow and we compared it to the white, which is 1 6, it meant that the yellow was, what'd you decide? I heard it all over the place.
I heard 5 6.
5 6. So interesting. All right, so what I'm hearing from you is this little white cube is pretty important. Yeah. What is that little white cube representing to us?
1.
In this case, 1. And we would call that a unit. A unit. But let's look now at the red. If it takes 3 red to represent 1 dark green, then what would one of those reds?
I know it wouldn't
Represent.
It wouldn't be a whole. What do you think?
What do you think? Okay, she think I'm hearing 2 6 all over, but I want you to see if you can see it another way.
Another way?
Because you're breaking it down to the white ones, but I want you to forget about the white ones for a minute. You told me how many red make 1 dark green.
3.
So I'm wondering what one of those 3 reds would represent.
Wait.
What would one of those 3 reds represent? Think about it.
Put your
Think
three. She's
about it.
talking about if you had 3 reds, what would 1 be? What would that? Can you look at it a different way though?
Don't compare it to white. We're
Don't
comparing
compare
it to green.
Oh, we're doing it.
What do you think?
Not light green,
2
dark
6.
green.
If you're comparing it to white, it would be 2
Our
6.
one
But she's asking to think of
whole
it
is
a
dark
different way. Just have the compare it with the green. What is it? Now.
No, we're just using these. All right, guys, pause for a minute.
So what would 1 be?
Let's do this. Class.
Yes.
All right, so I'm still seeing you guys grabbing other colors. This isn't about any other color except for red and dark green. So we just broke down, we separated dark green into white, and we found out that one of those whites compared to our whole would be 1 6. I want you to forget about that for a minute. Now we're looking at the 3 red compared to the dark green. So those are the only ones that you should have out. If it takes 3 reds to represent 1 whole that is dark green, then what is the fraction of one of those? So go back to it.
If you're comparing it to the white, I want you to just look at the green and the red.
How many?
Don't compare it to the white. No more white.
It's confusing.
Just the green and the red. How many did it take?
1,
3. So what would 1 be? We're so close back here.
We are.
You're just not
So I'm
saying.
gonna give you a little bit more, okay? Here's what I want you to look at. When we are, let's get our hands off the tools and eyes and ears up here. When we are breaking apart that dark green, can we break it apart or separate it only one way? No, you already proved that. You did it with white, okay? You did it with red. You did it with light green, right? Those are the ones that we were able to do with the same size, where we weren't mixing colors, right? So those are the ones we're focusing on. So if I took the 6 white and I compared it like we did before, how many parts did we segment the whole into? So when you broke that dark green apart into the whites, how many separate parts did we segment it into?
3.
With the white.
With the white.
Oh, 4.
Say it louder.
6.
Own it, girl. 6, right? So we said when we broke it into 6 parts, one of those represented 1/6. Okay? Then we said forget about that. Let's look only at the red. When we look at the red compared to the dark green, how did we segment? What are their how did we partition the dark green with the red? How many parts? So just tell me the parts. How many parts? Not the fraction. How many of those? How many reds? So the bottom number, the denominator, is going to tell me what kind of parts. 3 reds, right? When I grab one of those reds,
The light bulb just came on over here.
when I grab one of those reds, what fraction do I have in my hand? Grab it. Grab one of those reds compared to the dark green. We know that it took 3 of them, but one of them represents what fraction?
Just 1.
1/3.
Yes,
1/3.
there we go. Yay.
Okay, I want you to sit on that for a minute. Okay? Look back at what we just did. We took dark green, we partitioned into reds. How many reds? 3. And when we grab the one piece out, we know that that 1 represents what fraction? 1/3. You got it. You got it. Ooh, we persevered through that one, didn't we? All right. So this is all going to become clear as we move forward. Right? So here's what I would like you to do right now. I would like you to kind of set those aside for a minute, because we're gonna be looking up here for a few minutes. Do your best. Like if you have to keep your hands underneath your legs, not play with them. You know, like I get it, because they're colorful, but they're fun.
They're so tempting.
All right, so I'm gonna need some help up here again. Okay, somebody help me out with this first little tiny. It's just a sentence. It's not even a paragraph. And this is going to tell us about relating fractions and unit fractions. And we're going to figure out, what do you mean unit fractions? We've already explored and found it, but we just haven't given it a name yet. Can you read that all the way back there?
Yep.
All right, can you read this part for us?
When you separate things like figures or number lines into parts, you partition them.
Oh, and you heard me say that. So when we take the dark green as a whole and we separate it into parts like red or yellow, light green, what word are we using? We are partitioning. So it's basically like cutting, right? Separating, all right? Let's go to the second part. This is a little bit bigger. Let's do this. Let's have someone read from here to this period right here. Who would like to do that for us? Okay. All right, go ahead.
In a fraction, the denominator is the number below the fraction bar and tells you the number of equal parts that one whole is partitioned into.
Okay. Let's learn about the next big word. We did denominator. Have you guys heard about that word before?
Yeah.
Let's hear about the numerator.
Okay. The numerator is the number above the fraction bar. It tells you how many of the equal parts to use.
All right, so these are the big words we're going to be using right now, okay? So here's what I need you to do. We're going to get out our books, all right? And we are on page, if I can read it, can't read it.
I know, right?
They're small.
They need to make the print a little bit bigger. Let me see if I can find it.
The orange
95, guys,
Yep,
95.
Go to page, actually 63.
The one we always get into.
63.
Oh, 63.
Yep. All right, so on 63, you're seeing where we just read our learning intentions. And then you're seeing where we are going to have a chance to sketch what we just did. All right? So you took the dark green and you created some really, I'll use a big word, maybe we haven't used it yet, but equivalent rods, yeah, that are the same length. We talked about it last year, or back here. We knew that we had created equal because they were the same length. But what I want you to do is I want you to take your pencil and I want you to, if you want to trace the dark green, you can, or if you just want to eyeball it, but you want to draw under number 1, we're sketching the dark green.
Put together, that's the easiest thing to do.
Probably it'll be better to do it this way. It'll give you more. But I'm going to have you sketch 2 different ways. So we used our color rods to make 2 other ways to represent the whole, or a bunch of other ways to represent the whole. I want you to sketch 2 of those ways that you used. Okay?
So
Yeah.
do we like put it up?
But remember, if they equal or they're the same as the whole, they represent the whole, it will be the same length, right?
I think. Did you want them to use the same color, Rod?
One purple and 2 red.
Same
Here,
color?
let's do this. Do one that we did with the same color, and then go ahead and do another. Or you can do both of them the same color. But if you want to do one that used the mixed color, you can. But let's have at least one that you used the same color. All right, so here's what you're going to do next. At the bottom of the page, it's telling us to write the fraction for each part of the whole in your sketch. So on the dark green one, what does dark green represent?
A whole.
1 whole. How would we write 1 whole as a fraction?
1 out of 1?
Is that what you were going to say?
Yes.
1 out of 1. So we would have our 1 as the numerator, our fraction bar, and then 1 as the denominator. That's one way that we could write 1 whole as a fraction. We'll learn a lot more about that later. All right, so on top of the green one, you're going to write 1 over 1, which equals 1 whole. All right, now depending on what you did next, if you did the 3 red, then we already said each of those 3 reds is going to represent what fraction?
1/3.
1/3. So you would have 1/3, 1/3, 1/3. If you used all the whites, what would we have?
6.
1/6, 1/6, 1/6, 1/6, 1/6, 1/6. Okay.
I found a new
Write 1/3 on each.
Okay, so you're writing the fractions on it, and then you can choose. Yeah, there's a bunch of ways to
You
go there.
can do
So what's this?
3.
All right, so I have another friend over here. What color did you use?
It would be,
Ollie used 2 light greens, so we didn't talk about that one, but what fraction would 1 light green be?
1
this was how much?
1 out of 2, or how would we say that? 1 half.
1 half.
1
How many of
half.
these did we need to make the green?
What I use the purple
Okay,
and
so this would be 1.
I use 3 greens and then 1 white.
All right. So we're not going to get bogged down in that. I want you to look at me for a second before we go on to this next piece, because we're going to be folding some paper to make fraction strips. It's so fun. All right. Before we go on, what do we do though? Some of you built some holes out of mixed colors. So if I have 2 different colors, how would that affect the fraction that it would represent? I mean, if they're all white, I know that I have 1/6. One of those is 1/6. If I have all red, I know 1 is 1/3. Well, like, what about if I used yellow and white? What would that do?
It would change the fractions. So the white would be 1/6, and the yellow would be a different fraction.
So what would happen to the denominators?
The denominators would have different numbers.
Yeah. So if the denominators have different numbers, they would represent a different part. But we could also have different numerators, couldn't we? Because I saw some of you did like 3 whites and then another color. So which do you think we would call a unit fraction? The ones that have a 1 on the top with the same denominator, or the ones that you made with different colors that might have different numerators and different denominators? What are your thoughts on that?
A unit, what a unit means.
Talk to your friend a minute. Remember a time that maybe you used or talked about units in math before, and what does it mean? I'm thinking about base 10 blocks myself. What is a unit represent? What number? If it's a unit. So it is a digit or a number, but think about which one specifically.
Why do you think that?
It's made up of units.
Okay, 1 part of the
40. 2 more.
Okay.
Yes. So what unit might be?
How many you're going to look?
It's in my head, but like it's not coming out.
You just said this is 1
Block,
or 1
centimeter,
1 part of
or 1 part. You got it. You got it, girl. That's it. What is your name?
Zamaya.
Zamaya. All right, guys. I just had this great conversation with Zamaya. Sorry. Totally just said it. Don't worry. I keep calling people different names today. Zamaya was just thinking out loud with us, which, by the way, I love. And she was holding up. Show them what you were holding up. So she's thinking about the white, but she could also be thinking about the red or the green. And what did you say?
I said the white block is represents a part, or hold on.
How many parts?
Yeah, how many parts? 1.
She said it
Yeah.
represents 1 centimeter is what she said at
Yeah.
first. And I said, yeah, so 1 centimeter would be the white block if we thought of it as a centimeter cube. But when we think of it as partitioning, we know that that's really 1
Block.
or 1 part. All right, so guys, when we have 1 as the numerator out of a certain number of parts, that 1 lets us know that we're dealing with a unit fraction. And those are
Braxton said
really
one,
important.
it was 1 part of the whole.
And the whole can represent different parts, right? We just did that. If the whole is represented in this case by red, how many parts?
No, if it's red.
Red. 3. If it's light green, where's my light green Ollie? If the whole is represented with light green, then 1 part, or one of the pieces is 1. You drew it right there. Would you say, how many light greens did it take to make the whole? What'd you say? 2. So it'd be 1/2. All right, so listen, this is the first time we've talked about this, and we're just gonna let it sit in there. All right, so sit in there. We're gonna keep building on it, but you guys are doing great here. And we are on page 64. All right, so I want you to analyze. Analyze means to look closely. So we're gonna get our eyes peeled. You can look up here, or you can look on page 64. Analyze the bar model. Kind of looks like our colored rods, doesn't it?
Yeah.
Yep, so analyze the bar model of 1 whole partitioned into equal parts. Oh, well, we weren't talking about this word before. So let's think about that. How do you know that's partitioned into equal parts? Go ahead.
I don't know for sure if I'm right, but I think how we know it's equal parts because if you think about it, if you line them up together in your head correctly, then you realize that it's like not like this big and then this big.
So just like we did with the colored rods, right? When
Yeah.
you took the red and you lined them up end to end, underneath or beside of the dark green, you were looking to see, and I think it was, is it Raylan?
Yeah.
Raylan said that too. I knew they were the same because they were the same length. So I know that the red was equal parts. We can't tell for sure because we can't take these off of here and like move them, or we could measure them, right?
Yeah.
But we can eyeball that. And would you agree it's equal parts?
Yeah.
All right, if that is broken into equal parts, then how many equal parts did we actually break them into? Four. Do you agree?
Yeah.
All right. So thinking about what we just did, what would each of those represent as a fraction? It's partitioned into 4 equal parts. So if I was going to give these 4 equal parts a fraction name, what would it be? All right, talk to me. What were you talking about? What were you guys talking about? If those were 4 equal parts and we were going to give them some fraction notation, give them fraction names, what would each equal part represent in terms of a fraction? Yes, sir.
I think it was 1/4 because there's only one bar and there's only and then you have one.
So your numerator would be 1 because it would be one of the parts out of how many? 4. You're right. Yeah, so we would have the kinds of parts that we broke it into were fourths. Can you say that? Fourths. It's that tricky thing again where we have to put that THS at the end. Fourths, right? 1/4, or we could do fourths. If there's more than 1/4, then it's a fourth. Okay? All right, so if we were going to write down there on number 1, use words to complete the equation to show how the model was partitioned. 1 equals 1 what? 1. So since we're talking about 1/4. All right, so go ahead and write that in. And once you get that written in, 1/4 plus 1, finish it with me. 4th plus 1/4 plus 1/4. Once you get that written in, I want you to do me a quick favor. Put those colored rods back in your little bag or your box. Tuck it away because we're going to start with our fraction trick. In total. Yep.
And this thing said, what would that be called? And I said,
So you're telling me, you're telling me that 1/4 is a fraction.
1/4 is right because it's divided into fourths, and if you put it all together, it's 1/4, and that's called a unit.
A unit?
Number.
You said it a minute ago. What kind? A unit? You got it. Help him out.
Oh, yeah.
Unit fraction. Yeah, he said we were talking about it, and we knew that if we took 1/4 and 1/4 and 1/4 and 1/4, we would get a whole. And since that's the case, I know that each one of these is a unit fraction. I mean, that's some good thinking. That whole group right there, you need to tell each other good job, good thinking. All right, so we're going to do one more thing real quick right here. We just wrote 1/4 plus 1/4 plus 1/4 with our fractional word fourth, but now we're going to actually write it as a fraction. So how would you write the fraction 1/4? 1/4. What would my numerator be? 1. And then I'm going to have under my numerator, what am I going to have? My fraction bar. And then I will have my denominator of 4. You got it. So we're going to go ahead and put that in there. 1/4 plus 1/4 plus 1/4 plus 1/4 equals what?
Wait.
One fold.
So we'll switch it.
Write the words down.
Wait.
It's okay.
Yep, we used the word first, now we're using the actual fraction notation. We're making
Wait, I'm
fractions.
confused.
You're supposed to write the word fourth. Now you write it down here as a fraction.
All right, once you've done that, I want you to take one of your fraction strips and I want you to hold it in your hand for me.
Hold on.
Just one. So we're gonna take one of your fraction strips. You're gonna hold it up like this for me so I can see that you're ready. And we're gonna do some partitioning.
My philosophy.
All right, looks like we're about ready. All right, so our first fractional representation of whole that we're going to make is going to be to fold this strip into 4 equal parts. So no, don't just start, because don't start yet. I mean, it's not the end of the world if we put an extra crease in it, but I think if you think about it first, you'll be able to do this pretty easily. If I want to fold this strip of paper into 4 equal parts, what would my first fold be, maybe?
Probably like this, 2, like this.
So, in 2, which would be in half, because if I do that, now I have how many pieces? 2. All right, so I've got it in half. What would I do next to make 4? Oh, so she's saying fold it in half again?
Yeah.
Should we be brave? Let's try. Fold it in half again.
Oh yeah, that works.
Did it work? Open it up and see. Did you get 4 equal parts?
Yeah. Yeah.
Yep, let's touch and count each one. 1/4, 2/4, 3/4, 4/4. Each of those parts representing 1/4. Okay, so here's what I want you to do. Hold it like this. Now listen carefully. We're going to fold back just one of those. Fold back one of those. Now what do I have?
Like this.
3 what? Oh, did you hear that? We have, how many fourths do I still have? 1, 2, and 3. What? 3 fourths. We're still in fourths, right? So this is actually 3/4. If I unfold, now I have the whole, which is 4/4. Here's what I want you to do. I want you to take your pencil and on each of these parts, I want you to write the unit fraction that it represents. So if it's a unit fraction, what's your numerator going to be? 1. And your bottom number is going to be 4 because the bottom number, the denominator, tells us what kind of parts.
I thought you were gonna do like 1 and then 1
So,
and then
1/4, 1/4, 1/4, 1/4. Yep, you've got it. Remember, the numerator tells me how many parts and the denominator tells me what kind of parts. In this case, we have 4. So it's not, this would be 1/4, 1/4, 1/4, 1/4. All right, same thing. 1/4, 1/4, 1/4.
On both sides or just on one side?
You can do it on both sides if you want. That would work.
That's 1/4. This one's 4. You're right.
All right, once you've done that, I want you to grab your second strip. Second strip. All right, So second strip. If I were to take this strip and I were to fold it into 3 equal parts. So I'll give you a hint. Sometimes when I'm trying to do it, I don't like crease it. I just kind of play with it real softly, like bending it around and see if I can figure it out. And then when I'm like, oh, there I see it, then I crease it. So maybe I try that. 3 equal parts.
When you think you know you have 3 equal parts. I drop it.
3?
That's how many parts now? 2. So is there any way to fold that down to make it a third part? Well, that made, when we did that, that made what? It made 4. Jackson's so excited. He says he's got it. Let's see. I got it.
Fold, and I know this was a little tricky. I want you to watch me. The way I do it, remember I said I kind of just gently play around with it, try to get it to overlap, and then I'm like, that looks pretty close. We're not going to be perfect because we're not machines. And then I crease it, and then I unfold pretty close, right? Right, so if I have 3 equal parts, then I have the kind of parts I'm working with are 3, right? So there's my denominator. But each one of these parts, because they are equal, are going to represent 1 part out of 3. So what fraction would that be?
1/3.
1/3. You guys are so good. So we're going to again label 1/3, 1/3, 1/3. 1/3, 1/3, 1/3. I want you to hold it up and I want you to fold back one of those 1/3. And what do I have now? Think for a minute. Don't just yell it out. Think what fraction I have now. If I fold back one of my 1/3, one of my unit fractions, I fold it back. I'll tell you what. Practice with your group. Tell your group what you think, and then you'll have a chance to like, ooh, maybe I wasn't thinking right, or I thought about that. What do you guys think? What?
You don't see the piece. You folded one in and then you only have two pieces.
Yeah? Okay. All right, so I think you guys are really starting to get this. We're going to get faster now. Tell me, if I had all of my thirds, how many of them? 3. 3 1/3 make 1 whole. If I fold one of them back, now I have how many thirds? 2 thirds. 2 of my 3 parts. 2/3. I heard a bunch of you say it. I heard a bunch of you say it. Okay. How you doing? Thumbs up? Starting to get it? Not there yet? It's okay. We have a lot of time to develop our fractions, I promise. All right, let's move forward. I'm going to get a little bit faster with this now, guys. We are now going to fold into 6. 6.
Oh, that's it.
So let's think about it. How did we get 2?
We,
Fold it in half.
Yep, how did we get 4?
Fold it in half. Fold it in half.
So how did we get 3?
Fold it
We
half.
did that tricky fold, didn't we? The 3 we just did, we did the tricky fold. I wonder if we used our tricky 3 fold, if it could get us to 6.
No. I got it.
How did you get the
Would our tricky 3 fold help us get to 6? What'd you do?
What do you think I would do to get 6?
You called the 3, and then what'd you do? So you got it here, and then you. Oh, I've got people doing it already. How'd you do it?
So I did one.
No, you can't rip it.
I got it. You never said that.
You're right, I did it, but the rule is you cannot rip it. Here, here. I'm gonna let you try again with the whole one. All right, so here's what I heard. Sophia told me that she called the three-fold the circle fold. So she folded it into the thirds, right? And then she creased it, and then what'd you do?
I folded it again.
She folded it in half after that. And that makes sense, because if I have three, and then I fold it again, what's that gonna do to my three folds?
Double it.
It's gonna double them. You guys are great. All right. So you know what we're gonna do? What are we gonna do to that strip that now has 6 equal parts?
Label.
We're gonna label it. So label your strip with your unit fractions of 1/6, 1/6, 1/6, 1/6. All right, you got it? Sorry, Declan, right? So Declan, you did get 6 parts. You're right. But remember, we're trying to make equal parts. So when you look at those, do you think they're the same size? Are they equal? Nope. And that's okay, because this is tricky. So let's try. Sophie said, let's do that fold that makes 3. Remember that one? She called it the circle one.
I did it this way to make 3.
How did you make 3? Oh, I see you did. I missed that you did this. So if this was all we had, like right here, then that would be 3 equal parts. But we have to make 3 equal parts out of the full strip. So that's okay. Let's do it again. Let's start with your 3. Let's do that little tricky circle. So when we do the tricky little circle, and we crease it, so unfold that.
The piece gets smaller?
Yeah.
Do those look like they're the same size? Would those be equal parts? Yeah, so maybe we can go ahead and label those with our unit fraction. 1/3, 1/3, 1/3. If you have your 6 labeled, 6 equal parts, make a whole. Each of my parts represents 1/6, a unit fraction. If I fold back one of my 6, what do I have? 5, 6. So good. Okay, guys, you're doing fantastic. Here comes the next one. We've got a couple more. Let's do 2 8s. Do you think we can make 2 8s? Well, if we're going to make 2 8s, first we have to start out by partitioning into how many parts? 8. So how would we get 8? Okay, we're going to fold it in half. There's our 2. So we fold it in half to get 2. I'm seeing you fold it again. That's going to give me 4. And then what? No, remember 6, we had to fold the 3 in half again. So if I've got 4 and I need to get to 8, fold it in half again, yes. So if I fold it in half again, so we're going to fold it in half, fold it in half, fold it in half. All right, so here's what I want you to do. Label it, and then I want you to fold it back to show me 2 8s. Label it and show me 2 8s. This is wonderful. We're not. I see it. Look at your neighbors. Show them your 2 8s. And if your friend is struggling a little bit, and you've got it figured out, maybe give them a little tip. Can you share with them how you figured it out? So remember, this is 1 8, 1 8, 1 8, 1 8, 1 8. So when I say show me 2 8s, the 2 is going to tell me how many 1 8s I need.
Right now, how many 8s do I have? 8 8s, right? You don't. How many 8s do I have now? 4 8s.
Yeah, we need 1 8, 1 8, 1 8.
So do you want to make 2 8s?
Yeah.
Let me see your 2 8s.
You want to help them? All right, here we go. Class.
Yes.
All right, I can do this all day with you. It's fun, isn't it? We're going to move on though, but before we do, I want you to help me. We're going to kind of consolidate what we just learned, okay? Let's think about when we partition and we're making these fractions. What does the denominator tell me? What does the denominator tell me? Jackson? The total parts that make up the whole, right? So we've used different total parts that make up the whole. What does the numerator tell me? Yeah, how many parts I need. So when I said, show me 2 8s, you knew you needed to partition your strip into how many parts? 8. But I only wanted you to show me. You only needed 2 of those parts. Good job. All right, so here's what I want you to do. Take those strips and just tuck them into your book, like back here, so that they're like a bookmark back there or something. No particular place.
All of them?
All right, do that really quickly, and we are actually looking at page 65. All right, so you are going to be working with a partner on this, or your group of 3, or how many you have. All right, but I want you to notice, we aren't using the strips anymore, but boy, these kind of look like them, don't they? We call these bar models. Say bar models. Bar models. Now, at first glance, what do you notice that's different? What's different about this than what we were just doing?
That is colored. For some reason, it's the left side is smaller, but the right side is bigger.
Oh, on this particular one, the left is smaller on these, and those are greater. Okay. I heard over here color. There's some color. So I'm recognizing too, those smaller parts that you're talking about are colored, and the other is not.
Number.
Is it labeled? No, they're not labeled like ours. So here's what we're going to do. We're going to use the model to write an equation to show how you can partition a fraction into a unit fraction. That's a lot of words. Here's what we're really going to do. This number tells me what about this model? Just the denominator. The denominator tells me what about this model? The model is split up into how many parts? Eyes up here. How many parts? 5. But look, is it split up into 5 parts?
No.
So what do you think we might have to do? We're going to probably have to think about that and figure out splitting it up into 5 parts. This numerator tells me, we just said it, what does the numerator tell me? The bottom number tells me how many parts the whole is broken up to. The numerator tells me
How many parts I need?
how many parts I need, right? So if I'm looking at this, could we use our pencil and break that up into 5 equal parts, do you think?
I can.
Let's try it. Use your pencil. Don't be afraid. Pencil's a race. See if you can break that up into 5 equal parts.
Hey, I got it.
That's okay. Remember, we're not machines. We're going to be off a little, maybe, but we'll be close. So let's count your parts. 1, 2, 3, 4, 5. Are they all the same size? Remember, that word equal is really important. Really, really important.
What can I do to do this? Good, Ryan. How many parts do you have? 1, 2, 3, 4, 5. And you add 2 fifths.
All right, and it's fine if you look over at friends have figured it out. What I'm really looking for, because I'm seeing some of you were able to do it, but maybe you did it in parts that weren't this important part.
thing.
The equal,
You just divided
right?
the purple section.
So let's take a look. We'll do this one together. If I need this to be in 5 equal parts, I'm noticing, and this one's a little hard because 5 is hard. I'm noticing that if I had another one of those, and this wasn't here, that would be about half, right? Yeah. And if I split those halves into halves, how many pieces would that be? 4, but I would still need one more. But I wonder if it would be close. So let's give it a try. I'm thinking maybe if I split that in half, and then I think about, that's another half, and then somewhere, is that pretty close? This one's hard, 5 is hard.
Yeah.
So if that was the case, then I would be representing, what does this represent? What fraction? 1 what? 1/5. So I would have 2/5, because I'm writing an equation, equals 1/5 plus,
What's another one?
it's another 5th, right? So 1/5 plus 1/5. This equation represents this bar model, right? So let's do one more. If this is 4/12, then we know up here the 2/5 was the purple shaded part. So now I've got it figured out. The 4/12 is representing what color? Green. The whole thing is broken up into denominator 12. But my numerator is shaded. So I know that this represents how many of those 12s? 4. So see if you can break that up into 4 equal parts. 4 is easy. What would I do? Cut it in half and then cut it in half again, right?
Each of these pieces. Cut it in half again.
And then what you're going to do is underneath you're going to write an equation that represents this shaded part, just like we did up here. So I want you to start with 4/12 equals, and then finish the equation for me.
So what does 4/12 equal? What is this one here? 4/12 equals, what would each of those be?
No, 4/12 equals, what is each of those? 4/12 equals, what is that unit fraction? What does each one of those represent? 1 what? 1/12 out of the whole. 1 what? 4/12. So this is going to give us 4 equal parts. 1, 2, 3, 4. Each of these is 1/3. Each of these is 1 out of 4.
Looks like this isn't in 12. 1, 2, 3, 4, 5, 6. I just count 6.
All right, I'm going to do this one with you, then you're going to try a couple with your partner. All right, let's look, guys. What do I know about this whole thing? It's broken up into what partitioned into what pieces? How many pieces?
12 pieces.
12 pieces. So I know my denominator is going to be 12. Each one of these equal parts is going to represent 1/12. So 4/12 equals 1/12. Help me. Plus 1/12 plus 1/12 plus 1/12. Together, that's 4/12. All right, listen. The third one is super easy compared to what we just did. So I want you to go ahead with your group, see if you can figure out that third one. Yep, you can do it with your group. You can do the third one with your group. Number 3, I want you to skim down to number 5. So don't do number 4 unless you're already working on it. Go down to number 5. And I want you to look at what we are now using. We went from fraction strips, well, we went from color rods to fraction strips to bar models to, what is number 5?
Line plot.
A number line. Remember Remember, because we said in the beginning, we're gonna represent these fractions in a bunch of different ways. So now we're looking at our number line. And you guys did some of this in 3rd grade, so you're gonna have to dig deep, go back there and remember. Okay, so try doing number 5. It's gonna be very similar. Or getting your thought finished. And let's come back together and talk about the difference between partitioning the bar models and partitioning the number lines. What's the same and what's different between partitioning our bar models and our number lines? Yep.
You can't visibly see the best as good as you could whenever they're with bars.
With the bars or with the number lines? Which one's easier to see?
Definitely the bars.
The bar, yeah. So there's a reason we went from you using the actual colored rods to our paper strips, to the bar models, to the number lines, because you're right. Each time we move to that different representation,
It gets harder and harder to see.
it's a little harder to see. So guess what we're building in our brain?
Challenge.
The ability to visualize. Visualize, it's so important. So it's okay if we don't have this 100% today, guys. We're gonna keep learning this, and it's gonna feel so much better when we come back to it next time. Because today we're doing like the really hard work, but you can do hard things, and you're doing it. All right, so, but regardless, whether there's the bar model with the color or the number line, what are we doing on both of them?
You are fractioning and representing.
We're representing fractions on both of them.
Representing
What is that word that we're doing when we break it or
breaking in parts.
separate it or look at it in separate parts? You got it. So we're partitioning no matter what model we're using. But here's the big thing that I'm seeing that you guys are going to get better at. When I come back next time, you're going to be experts at this.
Wait, you're
What?
coming again?
I'll be back another day. Yeah. So when we are breaking these apart into unit fractions, what is the key to keeping it a unit fraction? What has to happen to those parts? We're not robots, but we have to do our best.
You have to try to get them equal.
Say that a little bit louder.
You gotta try to get them equal.
Try to get them what?
Evenly.
Evenly. Or the word we might say is
What's our math word?
Equal.
equal. So everybody tell me that. When we're using these unit fractions, we need what kind of parts?
Equal parts.
Equal parts, right?
Equal fractions.
And that is tricky for us, but we can do it. And you have been doing it, and I'm super proud of you. All right, so. How you doing? You sure? It's afternoon. We've just done some math that's challenged your brain.
Yes.
We're gonna do one more part. So you have the reflect, okay? So if you flip the page over, at the bottom of the page, it's not a big one, guys, one question. All right, I need someone that has a good, strong voice that can read this question to us.
Can I pick the reader?
I would love that.
Okay, Alara, nice and loud.
Alright. How is partitioning 4/5 into fifths the same as partitioning 1/2 into fifths? How is it different? Use models, numbers, or words to explain your thinking.
Nice. So let's look at the first part. How is partitioning 4/5 into fifths the same as partitioning 1/2 into fifths? Right, so think about that first. It says that you can use models, numbers, or words to explain what you're thinking. So you're going to start out with how it's the same, and then you're going to also tell us how it is different. All right, what question do you have about what you're going to do right there? We're going to rally. Do you know what rally means? We're going to like find our second wind and give everything we've got in this last 5 minutes. All right? How you feeling about that?
Good.
All right. How about this? In your group, put put your hand in the middle. In your group. Here, turn around to, oh, okay. All right. Here's what we're going to say. On the count of three, we're not going to scream. We're just going to say it with our normal voice. Okay, normal voices, don't yell.
Normal voices.
We're going to say, we can do hard things. Ready? 1, 2, 3. We can do hard things. All right, let's do it. Do it. Show us how it's the same and how it's different. Okay, how is it the same? Once you're finished, I want you to put your pencil in your book right there and just shut your book for me.
How is partitioning 4/5 into fifths the same as 1 whole into fifths?
All right, so pencils in, close up the book, and I'm going to finish up with one last reminder. If we are going to partition a fraction or a whole into parts, like this question, if we're going to partition into fifths, whether it's a fraction like 4/5 or a whole, what we're going to do the same is we are going to partition into
What? How many?
how many pieces?
No.
How many parts? I see you. I see you. I'm seeing this. So remember, the denominator tells us we're going to partition into that many parts. If it's 4/5 or a whole, and we're partitioning into fifths, we know there's going to be 5 parts. The difference is if I partition 4/5 into fifths, then how many parts do I have? 4 of the 5. But if I partition the whole into fifths, how many parts do I have? 5. That's a good thing. All right, guys, listen, we pushed you hard today, and you hung really well with it, especially at the end of the day. So I want you to turn to your group again, tell each other, great job. I'm telling you, great job, and I can't wait to come back.